You've seen me messing around with carbon fiber nylon on the channel before. Today we're going to try out some carbon fiber PETG. This stuff promises all the benefits of carbon fiber reinforcement while being much easier to print. Let's find out. Welcome back to Cloud42, I'm James. Well, if you've seen my last couple of videos, you no doubt have seen my new plasma table. We have been cutting out sheet metal parts with it, and it is working great. Which means we're also at that dangerous point in the project where it's working well enough that there's a very real risk I won't ever finish it. And there is one more thing that needs to be addressed, and that's the computer. You can see I've got the computer sitting here on my welding fixture table. This is a 21.5-inch touchscreen monitor that's used to control the software for the table. And no doubt, the welding fixture table does a great job of holding up the computer, and it's very convenient unless I want to weld something, which I do. So I need to get this off of the table, and I'd like to get it permanently attached to the plasma table in such a way that I can just wheel the whole thing away into a corner when I'm not using it, pull it out, plug it in, and use it. Now, Langmuir Systems actually does make a laptop stand for this table, and I bought one, but I'm not really happy with it. It's a little flimsy, it's probably fine. The thing that I'm not real excited about is putting my nice laptop right on the plasma table where it's exposed to that plasma cutting environment. But more importantly, there doesn't appear to be a really good way to swing the laptop stand out of the way so that it doesn't make the table require more space for storage. I'd like whatever I come up with to be entirely within the footprint of the table so that it doesn't actually make it take a bigger space in the corner where I want to store it. So I want to build a stand that holds this monitor and the computer that's permanently attached, and I've got some ideas about how I want to do that. Let me bring you over a little closer and let's take a look. The frame on this plasma table is made up of this 2-inch powder-coated tubing. It's actually slightly under, it's like 1,975, but it's basically 2-inch tubing. And if I pull out one of these rubber plugs, then you can see how it's attached at the corners. There are just bolts through, there's 3 tubes that come together. There's a bolt through this direction, bolt through this direction, and there's a bolt from the inside of this tube that just goes down, so there's no bolt head on the top. But it's bolted in 3 separate directions. And I would like to just use the existing bolts as the mount point so I don't have to drill new screws or figure out how to get whatever I put on here around the bolt heads. And what I'd like to use is this 1-inch by 1/16 wall steel tubing. This seems totally sufficient for supporting the monitor, and I just need to find a way to attach it. And you can see I've already drilled some holes in it, and what I want to do is drop it right down in the center of this tube and intersect these 2 bolts. And I thought about just trying to get the bolts to hold it, but it's going to slide on the bolts and there's still going to be some movement. So what I want to do is 3D print a spacer to take up this space so that this will sit in nice and solid. The spacer will have a little bit of compression, especially when the bolts are tightened, to hold it firmly in place so that it doesn't rock. And then the bolts will actually support the weight so that it can't slide down. And to 3D print this, I've thought about different materials that I have, and I could print this with anything. But I'm particularly concerned about the weight of the monitor. It's going to be up high, and it's going to be cantilevered back over the table, and so there are going to be sideways forces on this. And as the table runs, the inertia is going to shake it a little bit. There's going to be sideways forces. As I tap the screen, there are going to be sideways forces. So I want something that's going to stand up and be really resilient under compression. So I've messed around with carbon fiber nylon in the past and found it pretty difficult to print if you don't have a printer with a heated chamber. And so I picked up a roll of this to try. This is 3DX Tech CarbonX. This is the PETG plus carbon fiber version. And no, I'm not sponsored. I paid full price for this. And this stuff is relatively expensive. It's like 58 bucks a roll, but we'll talk about this a little bit later when we see how big the part actually is. I think it's still a pretty good deal compared to other kinds of materials that I might use for this. Now, this is PETG, it's not nylon, so it should print like other PETG filaments, which are pretty easy to print. At least I've had great success with them. Plus, it still has the benefits of the carbon fiber reinforcing. So let's give it a try. Let's go into the computer and design something and see how it works. This is Fusion 360, and I've already got a model of what I want to build. So down here at the bottom, we've got the leg of the plasma table with the 2 holes for the bolts through it. And I've got a 1-inch square tube going up, angled back with a VESA 100mm square mount for the monitor. Now we're not going to worry about all of this today. We're worried mostly about this plastic plug that allows this 1-inch tube to go inside the 2-inch leg. Let me turn the leg off here so we can get a little closer look at this. And this is what we're going to make today out of 3D printed carbon fiber PETG. And it's just a simple rectangular plug with some rounded corners and some holes in it. Let's open up a new model here and sketch it up. Now I think when I model, I don't tend to model things in isolation. I tend to like to first model the things that it has to interface with. So we'll just do that quickly here. We'll come in here and I will create a center rectangle and we'll model the tube of the leg. So hit D for dimension, and I know this is 1.975 inches outside dimension, and I will model the other side here and just click on this dimension to transfer that value. So that's the outside. Now I'll hit O for offset, click the part, and now we have an offset here, and I can dial in the thickness of the material that I measured, which was 0.075 inches, and that gives us the shape of the leg. I'm not going to worry about the fillets in the corner because we're going to put a generous fillet on the part that fits inside, so anything else doesn't matter. Click in there to select, right click, extrude, and let's give it, I don't know, 12 inches. Give it a foot. So now we have a model of the leg. Now let's model the tube that's going to go inside of that. I'll click on this top surface, create another sketch. Could have done this in the same sketch, but I will do exactly the same thing here. Rectangle, center rectangle, and we'll just drag this out, put some dimensions on this, and this is 1 inch by 1 inch. So that's approximately the tube, and the wall thickness on this, I'll just hit O, and the wall thickness on this is 1/16 of an inch. So I'll enter the fraction 1/16, and that will give us the profile of the tube. Now this actually does have some fillets, but I will put those on after I model this. So I'll do exactly the same thing here. Right click, extrude, but this time we're going to go 2 sides. So in the down dimension, we'll give it maybe, I don't know, 6 inches down, and the up dimension, 12. Okay, so that is our tube. Now let's put some fillets on that. I'll just hit F for fillet, and I'll select all these inside edges. And I don't know, 30,000, that looks visually about right. Since nothing's going to fit inside, this is just aesthetic. Hit F for fillet again, and let's do all the outside edges. And do those 1/16 of an inch. That looks about right. So there's our tube inside of a tube, and now we just need to model the plug that's going to fit in there. So I'm going to model that on this same top surface. So I'll click there, right click, create sketch. And now we could do this in a number of different ways. We could try to actually fit it to this model, though I'm actually not going to bother with that. I'm going to instead parameterize the dimensions. I mean, I could just take this as gospel and say, okay, I'm going to offset from this edge and get whatever kind of fit I want from the inside and from the outside. And that's one way to model it. But I anticipate needing to tune the parameters in the future to tune the fit. And so I'm going to use parameters for that. So I'll say modify, change parameters, and we'll put in a couple here. Plug outside, and I know I want to start with 1.82 inches, and I'll add one for the plug inside. And this would be 1 inch, but I'm going to say 5/1000 of an inch would be a good fit. Plastic tends to be a little bit flexible, and this whole thing's going to get squeezed by the bolts, and so I anticipate that will give me a good tight fit when all of that is taken into account. So we'll go back and take this sketch on the top here and start drawing, and we'll use exactly the same process here. We'll do a rectangle, center rectangle for the inside and one for the outside, and we'll dimension those up. And this will be the plug inside dimension. And this will be the plug outside dimension. And if we go down here and look, that is offset to the inside of the part a little bit. And if we go over here, we can see that yes, that's offset a little bit outside of the tube. So nothing has gone wrong yet. That looks okay. Go ahead and say finish sketch, and we'll extrude this, right click extrude, take this down 5 inches. Whoops, minus 5 inches. I want it to go the other direction. And that's set to new body. Okay, we've got 3 bodies in here, and I want to keep those separate. So I'm going to go ahead, right click those, create components from bodies, and we'll go in here and give these names. This is the plug. This is the post. And this is the leg. And let me change the appearance of the plug. We'll just make it red, just so we can see that clearly, that that's the one that we're working on. Okay, so now I want to put a cap on the plug and to put a little lip on the top here. So let me just go ahead and select the plug as my active component, and then I will right click here and create a sketch, and I will project the outside perimeter here. And now I should be able to come in here and select, control click. Let me make sure I got the gap between them. It did. Now right click, extrude, and I want to pull this up. Yeah, 1/10 of an inch is fine. Join, and now that's been added onto the plug. Okay, that's good for the cap. The reason I wanted to activate just that one component is to make sure that this joined properly and didn't like try to join to the leg. So let me go back and activate the entire model here, and I'm just going to hide the leg now because we don't need it. Hit F for fillet, and I want to round some of these corners. 1/4 of an inch on the fillet there, and then I want to do modify chamfer, and we'll put some chamfers in a few places here just to make this print better, because we're going to print it with this top down against the bed, and the chamfers will help with elephant's foot. It'll also help it make it look nicer. Say 40 thou on the chamfer. Okay, so I think that's the plug. The only thing we still need in it is a couple of holes, and I'm going to go ahead and just model those up with sketches here. So we'll right click, create sketch, and I'm going to hit L for line, X for construction, and we'll just drag a construction line down here. Then we'll create a circle, and we're still have the construction line on. And I'm going to make these a little bit oversized. I know they're about 590, but I'm going to make it bigger just so there's a little bit more slop, so we're not so sensitive to the 3D printing parameters. So 625, which would be 5/8, and I'm going to dimension that down from the top. I measured this out, and it happens to be 0.777, which is super interesting. Right click there, extrude, and we'll just cut through everything. And then we need to do the same thing, but we're going to need to transfer this over. So I'll say construct axis. And so now we have an axis that we can use as a reference point when we sketch the other hole on this plane. Create sketch, line, X, so L and then X for construction. Drag that down just so we have a center line. And we'll do the same thing. C for circle. Turn off the construction. Make the circle. Dimension this up 5/8. Don't know why it insists on moving that back. And I'm going to project this sketch line And then I'm going to hit D for dimension. I'm going to go from that line down to here and take that down 2 inches. And extrude that through. And there we go. If we hide the leg and the post, this is the part that we need to 3D print. And I'll add some more chamfers on here just because I like chamfers. There we go. Let's send this to the printer. We'll slice this in Simplify 3D. So I'll just come up here, say 3D print, click the model, click OK. And the first thing it does is it asks me if I want to auto scale. Since I designed in inches and the 3D printers operate in millimeters, it asks if I would like to scale it automatically. I say yes, and it drops the part in. Now, I don't want to print with the lip on the top, so Control L allows me to select a polygon for the bottom. I'll click and it will auto orient and put that down on the bed. And there is the part. Now let's talk about settings. The material I'm going to use here is by 3DX Tech. It's called CarbonX Carbon-Fiber PETG or PETG. And you know, I've done some testing in the past with the Nylon X, which I found pretty difficult to print. You had to use a Garolite bed. There was a lot of warping, a lot of peeling. It was hard to control the dimensions. And I'm really hopeful that the PETG will be easier, just because PETG in general doesn't shrink. I can print it on glass with hairspray. It doesn't warp. I get really good results in an open frame printer. It looks like they're recommending a bed temperature of 70 to 90 Celsius and a printing temperature 230 to 260 Celsius. And that's right in the range that I normally use with other PETGs. I normally print with either eSun or Overture or Hatchbox are the three that I've used in the past. I've been pretty happy with those. So I'm just going to use the same settings I use with those on the CarbonX, and let's see what happens. So if I go in Process Settings, I am going to use my normal PETG settings for layers. We're going to do 1/4 of a millimeter. And with PETG, I always print the first layer at 120% so that it doesn't squish it down into the glass. I find that causes problems with it rolling and peeling off. And if you give it a little bit more breathing room, it lays down on the glass and it sticks just fine. Infill, we're going to run this at 25%. It doesn't need to be a lot. Rectilinear fill is fine. Again, given the properties of the material, I think that will work just fine. Since we're not shrinking the long strands, shouldn't be a big deal. For temperatures on the bed, we're going to start at 90, drop it to 80. Again, this is just what I use with every other PETG filament. And the extruder, we're going to run at 255. And that's right in the, 230 to 260 range that they recommend. It's at the high end, which will give us good layer bonding, which is, that should be fine. And then for speeds, we'll run 3,000 millimeters a minute. That's 50 millimeters per second. This is about half what I run ABS at, but I anticipate that'll be fine here. This is what I normally do with PETG because it's stringy. I don't know if this stuff's any different, but we'll give it a try. Now, I'm also not sure about dimensions. One of the problems that we ran into with the other material, with the nylon material, is that the overall dimensions were hard to control. It seemed to be spreading on the outside and spreading on the inside. So the holes in the center were too small and the outside dimensions were too large. So I don't want to print all of this. I want to print just a sample piece so we can take some measurements and see if we need to make some adjustments. So I'll double click on this. And one of the things that comes up here is the X, Y, and Z offset. Z offset is 256 and change millimeters. Let me change that to 56 and see what happens. And that was too far down. Let's change it to 156. Okay, so all I've done here is I've just dropped the part down through the bed and left a small section of it sticking up, but this is representative. So I should be able to 3D print just this section, take some measurements off of it, and we won't waste a lot of this filament. As you saw, this stuff is relatively expensive, $58, but I think it still makes sense for this kind of application, you know, compared to regular PETG, which is what, maybe $21, $23 a kilogram. This is a lot more expensive, but we're talking about maybe $5 or $6 worth of filament for a part like this. And my time in the shop making this out of any other material by any other process is going to be way more than $5 or $6. And if I hired somebody else to make it, or even if I bought this thing manufactured and it were free, I'd pay that much for shipping just to get it here. So I don't actually see the price of the filament being a big impediment if you compare this to other ways that I might make a part like this. So let me click prepare to print. We'll look at how this sliced, make sure it's doing what we expected, and that looks very reasonable. Let me send this to the printer, and then we'll see how it comes out and take some measurements. If you decide to print with carbon fiber filaments on your printer, just make sure that you have a hardened steel nozzle installed. The carbon fiber in the filament is very abrasive and it's very destructive to brass nozzles. In fact, you may not even get through an entire roll of filament without destroying the nozzle. Fortunately, hardened steel nozzles are available for pretty much all 3D printers, pretty much all hot ends. They're available on Amazon, eBay, and direct from most 3D printer manufacturers. I've got the part here off of the printer, and I gotta say, I just love the way I love the surface texture on these carbon fiber parts. The fill on the top of this is really good. The bottom layer printed really great. The surfaces feel good. They've got that sort of matte texture that you would expect from a carbon fiber filament. This looks almost exactly like the carbon fiber nylon. And let's see where we ended up on dimensions. Now remember, the outside dimension of this is supposed to be 1.8 inches. And let's see where we are. 1.8375, so we're what, 37.5 thousandths over? 36 thousandths over. Yeah, so we're close to 40 thou over. There's 38.5, depending on there's surface texture, so depending where you measure it, you know, we're close to, yeah, 36 to 38 thou over, 39 thou. Okay, so let's check the inside. Now the inside is supposed to be 1005, and there we're 983.5, so we're about 20 thou small on the inside too. Yep, same thing there. We're maybe 21, 22 thou small, and on the outside we're 18.5 thou large, 19 thou large. Okay, so what that means is, if we take round numbers, because I mean, we're talking about 3D printing here, right? This is not a machining operation. We shouldn't expect the kind of precision we would get from CNC machining operations. So we're about 20 thou large on the outside and about 20 thou small on the inside. Now the great news is that means that the overall dimensions of the part are just about correct. We don't have some kind of a systematic scaling error from shrinkage, which is sort of what we would expect. PETG doesn't shrink much, and the carbon fiber is probably preventing what shrinkage there would be. So we just need to adjust the walls. And so if we're 20 thou large on the outside and 20 thou small on the inside, we should be able to just push the walls back in about 10 thou, which is what, about 1/4 of a millimeter, and we should be pretty close. Let's go in the computer and make that adjustment and try this again. Again, back here in Simplify 3D, we'll go back to the model, and we actually want to print the entire model this time after we make these adjustments. So I'll just do the same trick, hit Control L, click on a surface I want on the bed, and we're back up on top where we can print. Now we need to adjust the sides. This thing is spreading. The outside is oversized by about 10 thousandths of an inch, and the inside is undersized by about 10 thousandths, which means that our overall dimensions are pretty much right on. We just need to adjust those surfaces for expansion. So I'll go in here to Process Settings and come over to the Other tab, and we have a setting down here called Horizontal Size Compensation. And so I want a negative value. If we hover here, it says a negative value will shrink your model outline, which is exactly what I want. And it'll shrink it on the inside, which will make the holes bigger. And so I need a negative value. I need to make this negative 10 thousandths of an inch, which is about 0.25 millimeters, so minus 0.25 millimeters. Okay. We'll re-slice this. This looks right, and I'll send this to the printer, and we should expect to get a usable part out of this with the dimensions pretty much right on. I get lots of questions about what exactly this printer is, and it's a bit of a unicorn. It started life as a frame kit from a company called Maker Farm that I don't believe is any longer in business. It's basically, an i3 kind of geometry. I sourced the electronics off of eBay. The extruder is my own design. It was running a pair of E3D V6 hot ends. The bed is borosilicate glass, usually with hairspray, but I have some different materials I put on there, and they all sit over an industrial silicone heater that heats up really rapidly and maintains temperature really well. All in all, this has been a really solid printer. I've been running it for 6 years, maybe a little bit longer, and the only thing I have ever done to it is replace the brass nozzles in the hot ends as I wear them out. I do all my production printing on this printer, so it sees a lot of filament, and it has just been a solid performer. And here is the full part. Again, I just love the texture on this. You can see that it was pretty nice and smooth and shiny down on the bed of the printer. In fact, you can see all the artifacts in the layers of hairspray that were there. The top surface is very clean and very well filled, and the whole thing, it's just got a little bit of a kind of a rough texture to it, and I love the satin finish. Let's see if we got closer. So we're trying to hit, what, 1.8, and we're at about, excuse me, 1.82, 1.8, so we're, what, there, about 3 thou under, and there we're 1 thou under. It's kind of a rough surface, so I'll take some averages. Yeah, 3 thou, 1.5. There we're 4 thou under. 2.5. Yeah, so this is really close. 1 thou under. I'm real happy with that. Let's try the inside dimensions. And that is dead on. Half thou over. I am going to take that. I am very pleased with that. So then we just need to see if this fits. So it's supposed to be 1005. Let's see what this stuff actually is. 1002, 1001. That should go in easily. Let's see if I can do this on camera, if I'm going to make a big mess. Make sure I'm putting it in the right direction so the bolt holes will line up. Yeah, that's going to go in. I just need to tap it down a little bit further. I'm going to take it over to the vise and do that. And it should get the holes to line up, and then we should be ready to try to drop it in here. Okay, well that ended up being way less dramatic than I thought it would be. It basically just put it on the vise, grabbed it with both hands, and just pushed down, and it just slid right to the bottom. So no dramas there. That actually looks pretty good, and lo and behold, the measurements work out, the holes line up. So now we just need to drop it into here, and that means I have to take the bolts out, which means the leg is coming off the table. Now I actually threw some sandbags on the other corner, and I traversed the arm and the torch all the way over to the other corner of the table. So hopefully when I take away the support here, the table will not fall over. If it does, we'll find another plan. So let me take out these bolts. And I'll go ahead and pull the spacer on this side. So you can see it's just a spacer that goes through, so it bears on the outside and the inside of the tube at the same time. Okay, so it's dropped a little, but it looks like it's going to stay. Okay, so then the question becomes, how does it fit in here? The answer is it's a snug fit, which is exactly what I wanted, but it looks good to me. Let's see if all the holes line back up. Every tool's a hammer. So I've got this set to the low torque setting, so I think it's only putting about 35 foot-pounds on it, which should be about right for this. And so then the question becomes, with that amount of force on it, how solid, oh my goodness. Oh my goodness, that is, okay, that is pretty good. I am impressed with how solid that is. There is zero rock at all. That is not moving at all. I think that is definitely going to work. Well, this is not so much a test of the material as it is a test of the dimensional fit, and that is perfect. The bolts have snugged down a little bit, put a little bit of tension on it, and there is no motion in that at all. I am really happy with that. I think that's going to work great in this application. And I think that carbon fiber PETG is just going to last forever in this application as well. Plus it looks nice. It blends in with the table. It's not quite as black as the other blacks on the table, but I think we'll let it slide this time. I think this is going to work really well. So next steps on this project, we need to bevel the top of this and put an arm on it at an angle. We need to make a VESA monitor mount, and we need to weld all of that together, and we'll do that in a future video. If you enjoyed the video, give it a thumbs up. Feel free to subscribe to the channel and stick around, and we'll work on this next time. Thank you for watching.